Okay, so last time we looked at the whole overall production of urine. Glomerular filtration is the first part of urine production, okay? Glomerular filtration rate is essentially the amount of filtrate that you create in a minute, essentially, okay? You want glomerular filtration rate to remain consistent. Why? Because remember, the whole point of glomerular filtration is to create filtrate, and we want to get rid of waste. So if our glomerular filtration rate is not consistent, what ends up happening is we're not getting rid of enough waste. Waste is going to build up in our body, which is like totally a bad thing, okay? Really a bad thing. So we're going to kind of look at like what happens if glomerular filtration rate is too low, or what if glomerular filtration rate is too high, to help you understand that. And then really if glomerular filtration rate is too low, we're gonna deal with that. If it's too high, we're also going to deal with that in different ways. Okay, so let's just assume our glomerular filtration rate increases. Okay, so what essentially that means is usually what happens is there's an increase in blood pressure. Whoop, my light went crazy there. And an increase in mean arterial pressure. Because remember, we're equating them to be the same thing. So you want to think about that as blood flows in here under a higher rate, that means hydrostatic pressure is going to be much higher. So it's going to push on the walls of the glomerulus more, causing an increase in filtration. And now you're thinking, oh, isn't that good because we're getting rid of a lot of waste? Yeah, that's not a bad idea. We're getting rid of a lot of waste, but it's since filtration increases, what ends up happening is flow increases. So how fast you're going through the renal tubule is actually going to increase. So what that means is overall, there's going to be a decrease in reabsorption, or tubular, I should say tubular, whoops, tubular reabsorption. So as you have a decrease in tubular reabsorption, what ends up happening is you actually end up with an increase in urine output. Okay. You increase in urine output because the filtrate is going so fast through the tubule, you can't reabsorb everything. So you actually end up having more filtrate, which means you have more urine output. That probably is going to decrease secretion a little bit as well. And this is partially, you kind of partially want this to occur because if blood pressure is too high, a lot of times that also means that we have an increase in blood volume. So to turn the system off, if we have a large amount of urine output, that will help make sure that blood volume goes back down again. Okay. But essentially, you don't want that to happen. So if blood pressure or MAP are too high, then usually what happens to decrease glomerular filtration rate is that you are going to vasoconstrict your afferent arteriole. So to stop this, one of the things you can do is vasoconstrict the afferent arteriole. And I know you guys are thinking, wait, doesn't vasoconstriction increase pressure here? Yes, but what we want to do is we want to decrease glomerular filtration rate, okay? So when I vasoconstrict this and I cut blood flow off, essentially what's going to happen is we're going to decrease blood flow. Okay, I'm not going to decrease blood pressure, but when I decrease blood flow, that's going to decrease glomerular filtration rate. And that is eventually going to decrease my filtrate amount and flow. So overall, I can end up having less urine output. Okay, that means I'm not going to get rid of too many substances. I'm going to retain as many substances as I possibly can. Okay, so in this This one, I'm going to think about like what happens if glomerular filtration rate decreases. And sorry, I should like maybe move that a little bit so you understand. This one is, let's say we increase glomerular filtration rate here. And let's move this over here. Let's say we decrease glomerular filtration rate. Okay. So again, if we're decreasing glomerular filtration rate, usually what that means is blood pressure or mean arterial pressure has decreased. A lot of times that's because there's a decrease in blood volume. So like you're dehydrated, you're bleeding out, something like that. What about increasing blood pressure? Increasing blood pressure could just be you're old and you have high blood pressure, or you drank way too much liquids and that increased your blood volume, or you walked into your test and your heart rate started beating really hard, and so blood pressure increased. Oh, that's why you have to pee right before your test. Okay. So the other one is, let's go with a decrease in glomerular filtration rate. Usually is because blood pressure is decreased because blood volume has decreased. So think about as blood flows in here, there's less force. So maybe I'll make like, kind of try to make bigger arrows here. Just think about bigger arrows right there. In this case, I'm going to have smaller arrows. Maybe I have less of those arrows because now there's less hydrostatic pressure. Okay, so think about less hydrostatic pressure. Again, here will be a greater hydrostatic pressure. Okay, remember hydrostatic pressure is the force of water. So because you're not pushing blood through the glomerulus enough, what ends up happening is a decrease in filtrate. Okay, think about this as your garden hose. If I turn on my garden hose a lot, it's going to spray a lot. That stream is going to be really fast. If I turn my garden hose on just a little bit, it's not going to stream as fast. I'm going to have a little dribble. That's the same thing here. I have a little dribble, so my filtration rate goes down, which means my flow of my filtrate decreases here. And as a result, now we can think about the fact that we're going to have an increase in tubular reabsorption. And because you have an increase in tubular reabsorption, you're pulling all this stuff out of your, right? You're pulling way more stuff out of the proximal convoluted tubule, out of the distal convoluted tubule. Essentially what that means is you're going to have a decrease in urine output. And in some cases, you want that to happen, right? You want to think about that, yeah, we kind of want a decrease in urine output because we have a low blood volume. So we want to retain as much water as we possibly can. But the big problem here is because glomerular filtration rate is so low, you don't get rid of enough waste. So now we're going to build up all this waste in our blood, which is not a good idea. So we want to be able to stop this. We want to prevent this from happening. So to stop this, one way that you can do that, again, is using your afferent arteriole. So in this case, we're going to vasodilate. Our afferent arteriole. And I know you're thinking, wait a minute. Then we say vasodilation is going to drop blood pressure. Yeah, but we're not worried about blood pressure here, right? So when you think about blood pressure and MAP, remember that's systemic. So all systems, the whole entire body. Here we want to think about, because blood pressure is low, it's causing a reduction in glomerular filtration rate. And I need to increase that so that my urine output remains consistent and I get rid of as much waste as I possibly can. Okay, so when I vasodilate that, you want to think about that's going to open up even more. So like just like make this bigger, right? So as I open that up even more, what you're going to be able to see is we increase blood flow. Okay, So in this case, we increase blood flow. And as we increase blood flow, we're going to increase GFR. And as we increase GFR, that means our filtration rate will go up, or our filtrate and flow will increase. So you're going to push more blood volume to be filtrate, and then your reabsorption will happen at a more regular rate, okay? So that's what you want to think about in terms of glomerular filtration rate. So you can actually do this overall, how you're going to regulate glomerular filtration rate and blood pressure, okay? There are two systems for this, and I hope this video doesn't end up being way too long, but it is what it is. So what we're going to see is if there's a decrease in systemic blood pressure, there's going to be two systems that are going to help us combat this at the kidney. One of those systems is really going to be essential for GFR, okay? Sorry, I'm going to take out my notes to make sure I did this right, okay? So you want to think about systemic blood pressure decreases / mean arterial pressure decreases. And you kind of want to think about why this would occur, essentially. Maybe you have dehydration. Maybe you're hemorrhaging. Maybe you have not enough sodium concentration in blood. All of those things contribute to the fact that you would have a decrease in blood pressure, okay? So since you have a decrease in blood pressure, essentially what's going to happen is glomerular filtration rate decreases, right? So we're going to try to locally regulate glomerular filtration rate. You're going to try to do this instantaneously at the kidney itself, at the afferent arterioles, so that you make sure glomerular filtration rate goes up before we kick in systemic blood pressure going up. So that's why there's going to be like two sides of this map here, okay? So as glomerular filtration rate goes down, essentially two different systems are going to turn on. One system is going to be that the afferent arteriole is going to not sense enough stretching. Probably be a shorter video if I could spell correctly. And when I say it doesn't stretch, don't think about it doesn't expand because of pressure. Right? If pressure is not very high, it's not going to expand enough. And because it's not going to expand enough, essentially the afferent arteriole on its own is going to relax its muscle. And I'm just going to abbreviate here. Okay, so that's going to cause just immediate vasodilation of the afferent arteriole to try to regulate glomerular filtration rate. The other thing that's going to happen is we're going to use the juxtaglomerular complex right there, okay? So remember, as glomerular filtration rate goes down, we're going to see a drop in filtrate and flow. This is important because essentially that is going to be sensed by a drop in sodium concentration. Okay, so the amount of sodium and chloride in the ascending limb drops. And you might be thinking, wait, what? Yeah, so remember, go back here. Remember how the ascending limb picks up sodium? Because the filtrate is going so slowly, you're pulling so much sodium that sodium concentration drops, okay? Like a lot, like way too much. That's essentially going to be sensed by the macula densa, okay? So remember our juxtaglomerular complex right here? So there's my descending limb. That's my macula densa right there. There's my afferent arteriole, my glomerulus, and my efferent arteriole. They're all part of my juxtaglomerular complex. Okay. So essentially what's going to happen is a chemical gets released from the macula densa. Where is the macula densa? The macula densa is a little bit of it is in the ascending limb of the nephron loop, and a little bit of it is in the descending, in the distal convoluted tubule. Because remember, that's what's coming back up. Okay. So that chemical for the macula densa essentially is really going to go in that direction, and it causes vasodilation of the afferent arteriole as well. I'm hoping this chart doesn't like confuse you, but that chemical is released from the macula densa and it causes the afferent arteriole to vasodilate even more. So as we vasodilate our afferent arteriole, okay, what that means is we increase blood flow to the glomerulus, right? And as we increase blood flow, essentially you want to think about you increase glomerular filtration rate, and you have more filtrate, you have like more flow, okay? So that helps combat a low GFR. What combats the high GFR? Again, you vasoconstrict. And remember, you vasoconstrict, so not as much blood is flowing into the glomerulus. And then you turn on some other hormones and stuff like that to help combat that as well. So this is glomerular filtration rate, okay? I'm going to finish the other side of this chart when I talk about in another video where I'm basically going to talk about how do you regulate systemic blood pressure and MAP, essentially, through a hormonal system. So there's another portion of this that's going to be using hormones. Okay, so I'll do that one next.